even this layer, I mean the core layers, can be fabricated by composite, which is the combination of aramid fibers and phenolic resin. And on this slide, we will focus on the manufacturing of composite by using prepreg, which means that we already had the fibers coated with uh, resin in the previous step, and we investigating the process of laying off one layer on top of the other layer manually by hand. This process involved in the cutting prepared to size suitable for the part, and then you need to remove the backing paper, because when you apply the resin to the fibers and the resin coat outside the fibers, and is semi-Q, is sticky, and therefore you need to apply the backing papers. And once you need to apply them together, and you need to remove the backing paper and stacking the prepared layers together, or ply or layer have the same meaning. But since you do it manually, this process is slow, labor intensive, and inconsistent, of course, due to the human error factor. And that's why the manual layoff rarely used in the construction of large composite components. And most commonly used pattern, especially for the aircraft component, is 0, plus 45, minus 45, and 90. As you can see on the right side of this figure, we have more or less the mirror layer with the orientation of the fibers create the angle of minus 45 with respect to the, let's say, horizontal direction. This also depends on the coordinating system that you have selected. Yes. Okay. Yeah, I have heard the noise, not noise, the sound, and think that simply want to ask me. Yeah, but yes, this is the time for you to check your attendance. Just type your name in the message, and I will check your attendance after 3. I have already mentioned when we create the laminate composite, it's important to fabricate it symmetrically. So it means that if you define the middle layers, and the other layers will be arranged symmetrically. So above the minus 45 degree layers, you have plus 45, and below still plus 45, and then 90, and then 0. Aim at creating the composite with quasi-isotropic properties. Why? It means that in different directions we have the reinforcement in these directions. So even if the force apply on following the 0 or 90-degree direction respect to the selected coordinating system, or whatever, and then the load can be withstand without damage, because we have the reinforcement in these directions, 0 and 90. So for example, 0 and 90 can carry the in-plane tension, compression, or bending load, and 45 degree fibers orientation with respect to the coordinating system can withstand the shear loads. So somehow called quasi-isotropic properties. That's why we tend to arrange the reinforcement randomly. This is the reason. To fabricate the composite with the properties approaching the isotropic properties, or we call the quasi-isotropic properties. We can use the pattern called the cross-ply patterns, which contain only two directions, 0 and 90 degree, and can also be used for the composite parts, supporting in-plane tension or compression loads, but not shear. Because you see on the top, on the example above, that only the 45 degree orientation fibers can withstand the shear load. Yeah. And the orientation of the plies or the layers must be symmetric. To ensure the material is balanced, or otherwise the composite may be distorted or rough after curing. So this can be the reason. And after stacking together, it means that the prepared layers, yeah, stack together following a certain pattern. Can be the pattern with 0, 45, minus 45, 90. Can be the cross ply pattern, and then you compact the system by vacuum back, and to remove the air. And during this process, for sure, uh, to a certain extent, the process will remove the buffer inside the resin, to increase the density of the materials. And one thing's, yeah, here is the release film with horns, layer cloth. Yeah, you see on the right side. Yeah, it's just something here on the right side. You have the prepared layers, yes, attached to each other. You need to apply the release film with horns. Why you need to apply the release film with horn? Because you put it into the how can I say, the below can be the mold, yes, and you apply on top with the layers prepared, and shape the layer prepared with the shape of the mold below, and then you apply several stack or several layers of the prepared layers with the direction as design pattern, and then you apply the release film, because after you perform the curing process, and then you need to release the part from the mold. Yes, and there will be the holes on the release film, because during the vacuum treating process, it will suck the air out of the system, and you need to the channels, something like the channels, to release the air and to eliminate the buffer. Yes, and try to avoid sticking to cloth. Yeah, layer cloth. Yeah, layer cloth. And layer cloth is used for absorb the excess resin and place over the prepared stack inside the vacuum bag. Yes, and then you apply the vacuum pump in order to suck all of the air outside and stack them together. The final stage, you perform the consolidation and curing inside an autoclave. Yeah. And you put both the prepack, the tool, the vacuum bag inside an autoclave, and inside we maintain the pressure and enough temperatures, and the prepack is compacted by the pressurized nitrogen, carbon dioxide at the relatively not so high. Here it's just 700 kilopascal. Mhm. At these temperatures ranging from 120 up to 180 degrees C in order to cure polymer matrix and to harden the materials. Yes, with the reinforcement inside. The influence, yeah, of pressure and temperatures have to consolidate composite, removing the trapped air inside the vacuum bag and the resin probably, and to cure the matrix at the same time. But you need to invest for the autoclave for producing the composite because this is one step for curing and it is quite expensive and it's just used for fabricating those components with small or not too large. If it's too large, and then you must have the too large autoclave as well, and then you see how it affect your budget. Yeah, you see the autoclave on the right side of this slide, and it's quite big here. But if you want to create, for example, the turbine, the blade of the turbine for generating electricity, for example, using the wind energy, yeah, and then this volume of this grave is not enough in order to store the blade, and then that's the reason that it's not suitable for producing the large side parts because the price of the autoclave itself is expensive and is add up to the price of the composite after the fabricating process. Yeah. And here now I would like to introduce to you the similar technologies uh, to fabricate the prepreg composite, but here we do not use, how can I say, did not perform with hands, but you use the automated tape layer of ATL to improve the productivities of the process of fabrication. So on the right side, uh, on the bottom right of this slide, you can see that yeah we have the tape layer head, yeah, which can help to automating increase the degree of automation for the process of fabricating composite using prepreg. This is actually the automated process to have layer up prepreg tape for fabricating the composite, and these composite can be used for both military and commercial aircraft. For example, this process can be used for generating the wing skin of the F-22 Raptor. It can also be used to fabricate the composite for spar ribs or I-beam stiffeners. Yes, yeah, and this can be used for in a similar type of aircraft, for example, A340, 500, 600, or even the biggest passenger aircraft like a 380. Since the the automated tape layer can be used to enhance the degree of automation, and then you can reduce the time and cost for laying up a prepacked table on tool. You you reduce the material waste, and you can perform better repeatability and consistency because you use the machine instead of using uh, the, the humans in the process of fabrication, and therefore you reducing the risk come from the human factors. You can use the CNC tape laying head to deposit the prepack on tune, as you can see on the right side. You can also remove the backing paper, so it's like the two-side tape, yeah, like in case of two-side tape, and applying the compaction forks at the same time together with heat in order to improve the tackiness and form abilities together with cutting, performing with also with the tape laying head. Probably it depends on how complex and what about the functionality of the head designed for the process. Afterward, when we have the prepack, yes, which already stacked together and formed to a certain shape, and then we perform the consolidation and curing process. And it's actually not suited for the highly contoured part. Yeah. And that's why the uh, tape, automated tape layer process is applied for fabricating the composite structures, having the shape like a plate. Yes. Otherwise, the head or the base will be complex. Yes, and will affect the qualities of the material after the fabrication. So do you get the point? So generally speaking, you have the materials, the fibers or the fabric impreg with the resin, partially cure, stacked together, yes, put inside the vacuum bag. Of course, we have to shape with the mold, with the mold, stacked together, put inside the vacuum bag, using the vacuum pump in order to suck all the air outside. And if there is a certain air bubble inside the resin, and this can be eliminated. And afterward, put into the autoclave at a certain pressure temperatures in order to support the curing process to harden the materials. And then release from the mold, from the vacuum bag, and then you have the part. And that's all. If you use the manual layer up, you do it by hand. If you use the automated tape layer up, you use the machines in order to help you to improve the productivities and reduce the inconsistencies coming from the human factors. Because we are humans. Sometimes we forgot something, sometimes we forget something, or we add more material or something like this. Yeah. But if you use the machines, and this can reduce the risk of inconsistency coming from the human. And that's the point. Yeah. And the other techniques, let's say, called automated fibers placement, AFP, also belong to the group of manufacturing composite using prepack. And this process used in automated production of large aircraft structures from prepack. So the layout of individual tiles onto a mandrel. Mandrel is like một cái trục. Thì chúng ta sẽ paste những cái sợi riêng biệt, cái sợi da cường riêng biệt lên trên cái trục, sử dụng CNC, đúng không ạ? Fiber placement machines. In fiber placement head tiles, which contain each tile, the tile contain up to 12,000 fibers. Yes. And we can collimate it to bundles. Đúng kiểu chúng ta có rất nhiều cái individual tile và chúng ta collimated, đưa thành cái cụm, với một nhóm gồm có khoảng 12, 24 hoặc là 32 cái tile để tạo thành một cái band của prepack, sau đó deposit lên trên cái mandrel là cái trục của chúng ta. Và khi cái mandrel này nó quay, đúng không ạ, thì những cái winding prepack sẽ paste những cái prepack lên cái shape của cái bề mặt của cái component, đúng không? Cái bề mặt của component. And when the head moves, you can steer the fiber. The head can stop and cut the prepreg, can change the direction until we build up the material to require thickness. This means that when you finish one layer and you can deposit the next layer on top of the previous layer. And since you deal with the prepregs, it means that the layer of fibers already covered with the resin. So you have the resin, it means the polymer matrix materials. You have the reinforcement, you have the stacking of these fibers together, and you already have the matrix outside, and then you can cue in order to harden the materials following the shape that the prepreg deposit on, like this. The AFP process, or the automated fiber placements, used to fabricate the last circumference and highly contoured structures. So as you can see on the right side, for example, the fuselage barrel, cái thân của máy bay, can be the pressure tank, the nozzle cone, can be the duct, but I do not know the structure in the airplane, the duct. The carbon epoxy fuselage sections of the Boeing 787 Dreamliner. And this is the applications of the automated fiber placement process used to fabricating the composite using prepreg. And the other category of fabricating the composite structural component is the manufacturing by resin infusion. Or we can call resin transfer molding. This means that you have the mold and you pour the molten resin to the mold. Yes. So you use these techniques, resin transfer molding, to fabricate composite parts having the size being smaller than 3 meters, like fan blade of the F-135 engines, ribs, cái gân chịu lực for fuselage, and empennage of the F-35 Lightning II fighter. So you have subcategory of this technique. Call it, for example, the closed mold process, and the other called the vacuum-assisted resin transfer molding. So probably we will We'll try to finish this slide, and afterward I will let you free. And if you have questions regarding this slide or the composite chapter, you can ask me. Please keep in mind that we have after we finish today, the class today, we will have 2 days left, and I will try to manage to complete the course on time, meaning that around 1.5 days for the or around 1 days for the more than 1 day for the chapter to finish the chapter 5, and then the remaining times for completing the chapter 6 or the last chapter of the course. So it's better to read it in advance so that we can skip uh, those parts that you can read on your own. You can do it on your own. Yeah. Resin transfer molding. For the subcategory of these techniques, we can see the closed mold process. We start with placing fabric inside the cavity. The dry reinforcement preform inside the mold, inside the cavity of the mold, the free space of the mold. Stack apply to certain orientation and thickness. Yeah. Please remember that fabrics, yeah, is the reinforcement. And ply here can be the prepared or can be the woven fabric, the woven fabric. And please remember that if we stack plies together, please do it symmetry in order to avoid the distortion, bending after the curing process. In different directions in order to try to obtain the quasi-isotropic properties of the materials, at least in plane properties. But if we consider the in perpendicular directions, so it cannot withstand as well as the in plane direction, the load following the in plane direction. You stack the ply to a certain orientation and thickness based on the design pattern, and then you seal and clamp it. Seal, clamp it. Yeah, to create the isolate volume, and then you pump the liquid resin with low enough viscosity, yes, too easy to flow and to fill all of the cavity inside the mold. With the high viscosity resin, so it's hard to fill on the area inside the mold actually, or unless you apply a certain pressure to the resin to fill, yeah, the tiny cap to mold. And afterward, you heat up the system to gel with curing the polymer matrix. And after curing, you have the hardened composite materials, and then you open the mold. Yeah, you open the mold and removing the part and trimming the residual edges and perform some kind of finishing for the composite parts. And with closed mold process, you can produce composite with high fiber volumes up to 65%. And this process suitable for aircraft structures need high stiffness because you use a lot of reinforcement. And to be honest, it's higher than what we have discussed, the matrix materials. But in this case, yes, the fiber is still called the reinforcement, and the resin is still the matrix materials as usual. Despite the fact that the amount of matrix material is smaller than 50%, smaller than 50%. And since you apply a lot of reinforcement, and therefore the part will have high stiffness, high strength, and high fatigue performance as well. And this can be used to some situations, some input material, which is difficult to completely infuse fabric with the resin. And the other process also belongs to the resin transformonic, called the vacuum assisted resin transformonic. Use the vacuum pump in order to suck or to evacuate the air from the mold, together with draw the resin through the fabric. The resin and the influence of the vacuum pump will percolate between the fibers until the mold is filled. And once the mold is filled, we perform the curing process at elevating temperatures. And then once the curing process is complete, you have your hardened composite, and then you remove it from the mold, and that's all. So it's simply you have the fabric inside the mold. Okay, you have the vacuum pump. Yeah, play playing two roles here. The first is to suck on of the air from the mold. At the same time, you draw the resin, yes, and let it percolate between the fibers and tow. And when the amount of the resin inside the mold is increased and up to the certain point is filled completely the cavity inside the mold. Yeah, and it's finished. The filling process, let's say, and then you perform the curing process at elevated temperatures and form the part. And you may need to apply the post treatment afterwards, like in the case of closed mold process, removing for the edge, or removing the part from the mold, and then you trim the edge and perform some kind of finishing process. And that's all. That's the point. Yeah. So, do you have any question regarding the first 20 slide of this chapter? Yeah. Simply like this. To be honest, if you want to know more about the process, yes, read the textbook for additional information. And if you have the conditions, just practice. Is That's the point. That's the point. For those who study the course of material science and engineering, they need to go to the lab and practice what they have learned. Yes. To fabricate the practical part is quite interesting, to be honest. Okay. So thank you for paying attention to the course today. It's not easy day because there were a lot of noise. Yeah, unfortunately, sorry for that. And thank you again for your attention, and hope you have a nice day ahead. And for those who have any question, can ask me. And this is time for me to check your attendance. And if you have time, just spend time on doing your assignment as soon as possible, and paying also attention to the cost of additive manufacturing because the deadline is approaching. Yeah. Okay. See you. Alo, thầy ơi. Alo. Thầy ơi, alo.